Next up on drawdown in land use is bamboo. Bamboos make for beautiful forest. Obviously, always anything you look at in China, often there are magnificent pictures of bamboo forests. Its ranking by 2050 is at number 35 with 7.22 gigatons of reduced CO2. The net cost for managed bamboo forests for managing carbon is at $23.8 billion, but net savings end up at $264.8 billion. It is a species grass that grows tremendously fast, and in fact some species it's argued that you can sit and watch them grow because they grow by the hour, visibly by inches. So this is the distribution of various species of bamboo around the world. Tropics dominate again, and there is some in Central America and North America as well. Here is a figure from FAO that shows contribution of world bamboo resources by continent. Asia dominates with 65%, and Africa has got a small percent as well, and then Americas have 28%. Countries with the largest bamboo resources are of course India, and China shows up here as smaller than India, somewhat surprisingly, and the other countries add up for 43% with various regions here, Indonesia, Myanmar, and so on. But this is bamboo resources, so it's not just forest cover. Another FAO PDF document lists provides these measurements of biomass in tons per hectare for months after establishment, so just months after establishment. So 70 months is almost 6 years, and this is showing above ground, below ground, and total biomass, and you can see that it can grow really fast, and it's a grass that if you chop off it sprouts again, so that way you can keep sequestering carbon if you know what to do with the harvested bamboo biomass. Of course, there are zillions of applications. It has a compressive strength of as strong as cement, and the tensile strength is supposed to be as strong as steel. So it is used very widely for baskets, mats, buildings, since it also replaces steel, cement, and so on. It can actually save a lot on carbon. It also has this special ability to bond carbon with what are called phytoliths, which is a silica structure that is occluded to provide hard carbon that can be locked up for a very long time and doesn't easily degrade, so carbon can be sequestered for a very long time. This is just a study that's showing that depending on the species and so on, there is a relation between phytolith carbon content and phytolith content itself of the leaf litter in a bamboo forest. But nonetheless, the main message of this paper is that if you manage a bamboo forest intelligently, you can actually use this ability to provide hard to degrade carbon in phytoliths to manage carbon sequestration as a major contributor to drawdown, which affirms the message in this book. There are some controversies. Not everybody buys into bamboo as a great carbon sequester, storage way of storing carbon. And bamboo, while it grows very easily on degraded land and doesn't need much resources, can just grow by itself very fast, it can also be an invasive species, so obviously one has to choose the bamboo species very carefully as well. So here bamboo is planted on 77 million acres today. We assume that it will be grown on an additional 37 million acres of degraded and abandoned lands. This is important, not to deforest or take over other forested areas, but use degraded and abandoned lands. Our carbon sequestration calculations include both living biomass and long-lived bamboo products, so where you lock up the carbon that's already harvested from photosynthesis, with an annual rate of 2.9 tons of carbon per acre, where bamboo is substituted for aluminum, concrete, plastic, or steel. There can be avoided emissions as well, which are not included in the total of 7.2 gigatons of carbon dioxide sequestered by 2050. An initial investment of $24 billion could yield a 30-year financial return of $268 billion. So, bamboo, there is a group of architects that also advocates bamboo as a good material for construction, bamboo houses, bamboo outdoor gazebos, and so on and so forth. So bamboo is definitely part of the solution here.